In this tutorial, we're going to learn how to create a neural network in JavaScript that learns the pattern of XOR. If you don't know what XOR is, it's actually a logic gate that takes two input digits to output one digit. If the two inputs are the same, it's going to output a 0, and if the two inputs are different, it's going to output 1. I should also mention you need nodejs and npm installed. I'm assuming you have them installed, but if you don't, I put the link in the description so you can download them. So let's get started. I'm going to create a directory for a project and call it XOR_NN. And also I'm going to open a command prompt. I'm using git bash, but you can use whatever you want. And I'm going to npm init to create our npm project. I'm also going to install Dannjs, so npm I Dannjs, which stands for Deep Artificial Neural Networks. It's actually this library that we're going to use to create our neural networks. And I'm going to create a JavaScript file, which is going to be our main JavaScript file, and open it with Atom. You can use whatever text editor you want, it doesn't really matter. I'm using Atom. Okay, so first of all, we're going to import our library. So we do it like so, require Dannjs. We're also going to import our dataset because Dannjs actually comes with testing datasets. So XOR is one of them, and we can log it in the console just to see what it looks like. So now once we run the file, nodeindex.js, we can see that's our dataset. It has two inputs, right? If they're different, it outputs 1. If they're the same, it outputs 0. That's XOR. So now that we have our dataset, we're going to add our neural networks. So this is done like so. Okay, and now we can go ahead and create our neural network. So I'm going to call it NN for neural network and make it a new Dan. And now we need to specify the number of input neurons and the number of output neurons. So I'm going to put 2 input and 1 output, just like XOR. And I'm also going to add a hidden layer. So hidden layers are a way to add neurons and parameters actually to a neural network. So I'm going to add 12 neurons in that layer. And I'm also going to create the weights because we need to tell the neural network once we added all the layers, okay, now it's fine, you can create the weights, which are the small synapses in between the neurons. So now that we have our neural networks, we can log it in the console and see what happens. Okay, so now we have a neural network here, and we can see it has 3 layers, one with 2, one with 12, one with 1. And one thing I'm noticing is the learning rate is fairly small. It's 0.00.1, yeah, and I'm going to actually reduce that to 0.1. It's going to be more fit for our task, and yeah, we can see that's better. So now we can go ahead and train it. I'm going to iterate through the whole data set we have, so data of XOR, and if we actually console log data. If you don't know how this works, it's actually just it iterates through the whole data set and gets you the data. So I'm going to backpropagate the neural network. So this is actually how you modify the weights. So a backpropagation is actually telling the neural network, okay, I want this as an input, and when this is the input, I want that as an output. But since we have the data set, we can just say data input and data dot output, just like so. And now it's iterating through every element and training the weights alongside. So we should be able to get a prediction now, right? We should ask your neural network some data, and it returns a prediction. So we do so like this, feed forward, just like so, and we can tell him 0, 0, and it should output 0 in that case. So if we see, oh, I forgot to log the feed forward, so you can tell it log true, and it's going to log it to the console. Okay, So now we can see it's pretty random, right? 0.27 is pretty random. We can run it again. It's also random. It's also random. It's also random. It's always random, right? Because we only trained it one time. We iterated through one time the dataset. So we should actually train it multiple times. So that's what's called an epoch. One time in the dataset, one iteration is actually an epoch. So I'm going to tell him to train 10,000 epochs and see what happens then. Oh, we can see now it's pretty close to 0. And now it's again pretty close to 0. And now it's again that one's less precise. But if we want to optimize this and have a better, more precise AI, one thing would be to add more epochs. But with this would come a lot of performance issues which are not that great. We can also use another activation function. We can see now for the hidden layer we're using sigmoid. Another one that's great for hidden layers is Leaky Relu. Actually, it's way better. So if we use Leaky Relu, just like so, we can see now that we train it, it's way more accurate. Because Leaky Relu is way easier to compute, and it's also, there's no cap, so it can go to infinity. And when it's a hidden layer, we don't really care about going to infinity. When it's an output, that's something different. You wouldn't want to put a Leaky Relu activation in the output layer, but for a hidden layer, that's fine, and it's actually way better. So now we can train it multiple times, and it's always very precise. So this is how you would create neural networks in JavaScript. This was a fairly simple tutorial where we learned how to create an AI capable of understanding the patterns of XOR logic. I really hope you learned something today. I'm going to put the links in the description for all the libraries and requirements used in this video. Don't forget to leave a like and subscribe, and see you in the next video.